Welcome to the session on analog communication practicals. Today we will discuss the demonstration of first practical DSBFC, that is double sideband full carrier. We will perform this experiment for three cases of modulation indices, that is m equal to 1, m less than 1 and m greater than 1. For performing this experiment, we will use three sections of this experimental board. First, audio generator section, RF oscillator section and balance modulator section. Audio generator section which provides modulating signal, RF oscillator section which provides carrier signal, and third, balance modulator section which performs the actual modulation operation. Let us see the demonstration stepwise. Set the message signal at 1 kHz frequency and 2 volt peak to peak voltage. Message signal may vary from 300 Hz to 3.4 kHz. Set the carrier signal at 455 kHz frequency and 2 volt peak to peak voltage. Here we want to generate DSBFC, that is 1 plus m of t multiplied by cos omega c t. First, we will connect modulating signal to the input of balance modulator section. We need to DC shift the modulating signal by 1 volt. This DC shifting of modulating signal is achieved by connecting this RF link. Note that carrier signal is internally connected to balance modulator section. Now connect modulating signal to channel 1 of the DSO and output of balance modulator section to channel 2 of DSO. Now at the output of balance modulator section, we will get DSBFC with m equal to 1. Now we will note down the Emax Emin values from time domain waveform of DSBFC. Also, we will note down L1, L2 values from corresponding trapezoidal display. We will then observe the frequency spectrum for m equal to 1. Now for the second case, that is m less than 1, we will keep all the connections as it is. We will only decrease message signal and we will make it less than 2 volt peak to peak. Automatically we can see DSBFC waveform on DSO with m less than 1. Now for this case, we will note down Emax and Emin values from the time domain waveform of DSBFC. Also, we will note down L1 and L2 values from the corresponding trapezoidal display. We will also observe the frequency spectrum for m less than 1. Now for the third case, that is m greater than 1, we will again keep all the connections as it is. We will only increase the message signal and we will make it greater than 2 volt peak to peak. Automatically we can see the DSBFC waveform on the DSO with m greater than 1. Again for this case, we will note down Emax and Emin values from the time domain waveform of DSBFC. Also, we will note down L1 and L2 values from the corresponding trapezoidal display, and we will also see the frequency spectrum for m greater than 1. Finally, we will calculate the modulation index for all the cases from Emax, Emin values and L1 and L2 values. Compare the frequency spectrum obtained in each case and write down the conclusion. Now, let us go towards the second practical, that is DSBSC modulation and demodulation. Here we will need 5 sections of this experimental board: audio generator section, RF oscillator section, balance modulator section, product detector section, and low pass filter section. Let us see the demonstration stepwise. First of all, set the message signal at 1 kHz frequency and 2 volt peak to peak voltage. Message signal frequency may vary from 300 Hz to 3.4 kHz. Set the carrier signal to 455 kHz frequency and 2 volt peak to peak voltage. Here we want to generate DSBSC signal, that is m of t into cos omega c t. Apply the modulating signal to the input of balance modulator section. Also connect modulating signal to channel 1 of DSO. Note that carrier signal is internally connected to balance modulator section. Now you can see DSBSC signal at the output of balance modulator section. Observe the time domain waveform of DSBSC signal. Also observe the frequency spectrum of DSBSC signal. Note down LSB and USB frequencies. Now for the demodulation, we will use the product detector section. Apply output of balance modulator section, that is DSBC signal, to the input of product detector section. Here also, same carrier is internally connected to product detector section. Else, this method of demodulation is also referred as synchronous detection or coherent detection. Now connect the output of product detector section to the input of low pass filter section so as to eliminate or remove the higher frequency components. At the output of low pass filter section, we will observe the recovered modulating signal. Note down the frequency of recovered modulating signal. Write down the conclusion from the observed DSBC spectrum and recovered modulating signal frequency. Thank you.